Thank you. Thanks a lot, everyone, for being here. Thanks a lot, Cody and Eugen, for organizing this. I'm really, really excited to be here. My name's Mrinal. I'm CTO and founder at Ockam. I am going to run a command and then talk about it after, because this is all going to take time. And so, KDAR 000. Increase the font. OK, thank you. That was helpful. How about now? Better? OK, so I'm in an empty directory. I'm going to type Ockam and then tell you a little bit about it. OK, so Ockam is a toolkit to build and run billions of collaborating AI agents in parallel. It is literally the easiest way to take an agent into production. And we currently have a long wait list. But for tonight, or today evening, we've opened up sign up. So if you want to try it, and if you find the content interesting, you can go to that QR code, which I'll put it up in a second again, and sign up today. OK, so in that directory, stuff's happening. While that's happening, let me go to the next slide. So what is it? It's a collection of features that you can individually go get at various places, right? So it's a SDK to build agents. There are a bunch of those, and you can go get them. It's a place to run agents, many of them. And technically, you could assemble that environment. You could spin up some EC2 machines, put some Python in it, and start running your agents. It's a place to connect agents, but not just agents running in that environment, but agents running anywhere. And technically, you could do that too, but it takes a lot of time, and it's complex, and involves a bunch of protocols, and authentication, and security, and complex things. And we've kind of taken all these pieces and made them simple to do, so simple that in 2 seconds, we can spin up an agent, have them collaborate, do stuff, and we're done, right? So the value proposition is time to market. Like you can, if you're thinking of building an AI agent or an AI agent startup, this is the easiest way to go into production, like today, if you want. OK, so what happened is I ran a command in an empty directory, and I already have an agent in production. If I say hello to it, it's going to go, hey, I'm Jack Sparrow, something, something in pirate accent, right? Because I told it to be Jack Sparrow. But what just happened is, in an empty directory, I typed one command. It downloaded a template project, and then it ran, it turned that template project into a Docker image, pushed the Docker image to a runtime in the cloud, and ran it over there. And the code for it looks like this. If you go to 000, there's a YAML file there that says, OK, I am the hello AI application. I'm running in the main pod using the main container. And the image main is described with this Docker file, which anyone who's a developer has seen these types of things. But this Docker file is just a Python environment with a main.py. And if you go to the main py, it's spinning up this class called agent, and this is our instructions to the agent. Our instruction is, you are Jack Sparrow, and that's why it replied back and spoke in a pirate accent, right? But the cool thing is, we didn't have to write any code, and it's already a running in production, ready to go thing, right? So I will run another command and then show you another example. So let me go to 003 now. OK. I'm going to do Ockam again. And let's go look at what's inside the 003 directory. So same thing. There's a YAML file that describes what to do. There's a Docker file, which looks a lot like the old one. But the main py is a little bit different. This time around, we're saying, hey, OK, you know what? Don't be Jack Sparrow, be Henry. And as Henry, you're a legal expert, because I'm getting ready to launch a legal AI startup that's going to help lawyers do their work a little bit better. And instead of using the default Llama model, why don't you use the Anthropic Claude model, right? And we changed a little bit of code, and Then we ran it. And a few seconds later, this thing's going to go into production as well. Now, when we see it running, we'll see a few things happen that you need in production. One, you need an agent to have memory. Two, you need an agent to have an API so you can build a UI on it, right? And three, you might need a UI. So actually, if you put an index.html into that directory, the agent will also automatically just get that as the UI, right? So the whole goal is make it simple to go into production here, right? So, okay, the thing is running. Our first scenario was, well, we want an API for this agent, so let's go see if it has one. So if I go over here and I say HTTP request, this is the URL of my app that was just deployed. And so if I go to that URL and do /agents, which I'm hoping everybody can see, if not, I'll make it a little bit bigger. And I hit enter, it's going to come back with an HTTP response, and it says, okay, you have a bunch of agents, actually just one, and this one is called Henry. Okay, so cool thing is we wrote almost no code, and we already have an agent that has an API. Not only that, this agent has a streaming API. So we can go, hey, why don't you stream your responses back to me? And so if I hit enter over here, it didn't reply in one message. It replied in many messages with I am Henry broken down into multiple different little messages. So that's how you get that ChatGPT effect of streaming your response. In addition, I said we want a UI for this agent, and that also got created. So my HTML page that I put in there can be rendered in a browser. So let me go over here, and now I have a UI for it. I'm going to say, who are you? And now, it's starting to look like a product, right? So the goal was have a product ready to put in front of customers as quickly as possible. So we're getting there. But there's some other things you need when you're taking an agent into production. And one of the important things is this notion of memory. And the idea with memory is that as you interact with an agent and ask multiple questions, it should remember the context of what it has seen, whether it's various data that you put into the context window or various questions you've asked. To do that, you need a place to store that memory, right? So Ockam already provisioned that database for you. It's a vector store. It already vectorized your inputs. It stored that information to be long-term available. So if your agent is running for years, it will for years remember its old context and can go look back. So if I go, what have I asked you so far? It will go, so far you've asked me, who are you? Questions about my identity, etc., right? Maybe I go, what is legal drinking age in sorry, I can't type in this drinking age, right? Okay. And then I go, what have I asked you? It's going to echo back that I've asked, the same thing twice, and what have I asked you so far, etc. So the idea is you got managed memory for the agent without you having to do any of the work, right? Okay, now I have 5 more minutes left, 6 minutes left. So now I'll show you a few examples, and we'll jump straight to a much bigger example. But just to recap so far, our first agent that got automatically generated looked like this, right? Our second agent was a little bit more specialized. It was like you're a legal assistant. Let's look at this one. So in this case, in this case, I want to have my agent deal with data that is private to me. And because it's private to me, and it's not in the agent's training set, I can feed it as this object called knowledge. And this knowledge can come from the internet, or it can come from a private data store, or it can even come from a data store that's living inside my company. And we have this capability called portal. So you can get a portal to a private Postgres database or a private SharePoint instance inside a company without requiring that to be public on the internet, and you can fetch data out of it. Not only that, we take that data and we turn it into embeddings and store it into a vector store. This process is called a RAG, and so you didn't write any code, but we created a RAG pipeline for you out of the box, and your agent is able to search through that RAG pipeline, right? Or that vector store that is the result of that RAG pipeline, right? So again, a lot of the work you would have to do yourself to build an agentic application just automatically done for you. Now let me jump to another one. So another common case is your agent needs to use some tools, right? And these tools might be a Python function. Like, for example, you might need a Python function to tell it the current date. So here I wrote a Python function that displays the current date. I must write a comment for that function because agents use those comments to learn. But if you were building this app from scratch, you would have to figure all of this out. In this case, Ockam just kind of did it for you. So we wrote a function to give agent knowledge about the current date. And then instead of writing more functions, we used a off-the-shelf MCP server called Brave Search, and we use that to give the agent the ability to search the internet, right? But the important thing is, you don't have to go figure out how to go run this Brave Search MCP server. All you do is in the YAML file, you define this little block that says, okay, I need an MCP server. This MCP server needs these secrets, the Brave API key. And to start this Brave Search MCP server, here's my input or how you can start it, right? And as long as you give it that information and the secrets, it will run the MCP server for you in the cloud and make sure it's always alive for your agents to use, right? Okay, another thing you might want to do often is create workflows with your agents, right? So in this particular case, I'm creating a workflow which is, I have several agents defined. My first agent is a triage agent that looks at some input and decides whether this is a security question or a code security improvement question or a network security improvement question or none. And I have a different agent that can improve the security of the code. So it's a fixer. I have a different one that says, is the fix good enough or not? I have a different one that says, oh, if this question is not about security or networks, bounce the response and go, hey, you know, I don't answer questions, anything not related to security, right? And so you take all of that, you arrange it into a little flow in these like 4 or 5 lines of code, and you go, okay, if it's triage, if the condition determined by the agent is network, then move it on to this network expert. If the triage says it's a other question, give it to the bouncer and bounce the response off saying, I don't handle these responses. If it's about code security, give it to the code evaluator loop. And loops are really important in this type of thing because agents or LLMs get stuff wrong all the time. So you want to create this feedback loop-like thing where if you give them a request, they come back with a response. If you don't like the response, you can tell them to do it again. And after a certain time, they'll meet the threshold, and you can then pass the result on, right? So you can create these flows. All right, I have now less than a minute left, so I'm going to now run my final example. There's a lot more that you can check out on our GitHub, but let me jump straight to 010. All right, and while this starts up, if anyone has questions, I'll answer them, and then hopefully we can take a quick peek at what happens and stop there.
All right, we have time for one question. Anyone?
You said there is memory, and how does it manage the memory behind in the backend? When you gave it questions and you had it, does it store it in the context? Does it store it in a database?
No, it stores the memory in a vector store, and it keeps a recent set of messages in context. Right? So you can kind of like basically get long-term and short-term memory out of the box. 2 seconds. Sorry?
What's the ratio?
So it's configurable. You can choose. And it's dependent on the model because models have fixed context length. And so you might want to choose the right ratio based on the model. Sorry? Yes. You can specify the embedding model. You can also specify a separate reasoning model. All right, it's running. Thank you for being patient with me. All right, so all that is good, but what if I want to do a very large number of things? So Ockam is built on the actor model, and inside one machine you can create millions of parallel concurrent actors, and you can have them send each other messages within the same machine or across machines. So in this particular example that I'm about to show you, I'm going to analyze 20,000 files on GitHub for security, and it'll happen only in a few seconds because what I'm able to do is spin up thousands of parallel agents in this environment that each individually handle a single file, and many are coming up, many are getting done with the file that was assigned to them, and they're all going to just go away. So 2,000 files were analyzed for security in just a few seconds, right? So this type of parallelism and scale becomes feasible once you've got something out of the box that helps you build and scale your agentic applications. So if anyone is interested, please scan that QR code and sign up, and I'm obviously going to be around and to answer any questions.